Hello, everybody, and good day. This is Oliver White coming to you live from beautiful Prague. Oh, wait, I'm sorry, that's not right. I'm in San Francisco today at TypeSafe's headquarters, and it's morning, not evening. Nonetheless, joining us today is Justin Pahony, who we're very happy to welcome recently to the TypeSafe team. Justin has a very well-developed a very well-developed background with Apache Spark. He's taught the Pluralsight course, The Fundamentals of Apache Spark, is listed in the top 5 profiles for Spark questions on Stack Overflow, and has even started to teach one of his cats a bit of Scala in order to prototype a new Spark project. So while I introduce today's session, I'd like to post a quick poll asking you about your experience or upcoming plans with Spark. Here we go. And because we're in San Francisco, you can hear the telltale sirens and insanity occurring at street level just below us. Today's session takes a bit of a step back from some of the deeper Spark materials we've been launching of late and is aimed more at introducing Spark to developers and data scientists that have long heard about the power and abilities of Spark but never really had much of a chance to look deeply into it. So in a way, you can think of this as the rise of Apache Spark explained, if you will. If you have any questions, please place them in the Questions tab of the GoToWebinar control panel or email me personally at oliver@typesafe.com. As always, a big shout out goes to our happy customers using Reactive Platform, and since I'm in San Francisco this week, I'd also like to call out a very interesting position that's open at IBM, who are looking for developers with experience in projects like Spark, Hadoop, and Tachyon to become part of their new Spark Technology Center here. It's a very exciting place to be and a very exciting new initiative that IBM is putting forward on Spark. So that's about all I have to say, and without further ado, let me hand it over to Justin. Welcome, Justin.
Hi,
Hi.
thanks for that intro.
You're welcome.
All right, so as we see here, today's topic is going to be fast data analytics with Spark. So let's take a quick look at today's agenda. It appears that we have some loading here. Well, that's definitely something we want to take a look at of why we would want to use Spark. We're tired of some of these slower batch processing things. We don't want people to see a loading screen. We don't want to have to wait for our data anymore. We want to have answers now. So really our agenda is going to be taking a look at some of the concerns around Spark. Why Spark has had it, as Oliver put, why it's had its meteoric rise. We'll get a better understanding of that. And then we'll also give a really high level of the basics of Spark, so you'll be able to understand why Spark is there, and then you'll also be able to discuss Spark a little bit more intelligently. As well as we'll do a brief topic covering on the common pitfalls of Spark and how we can help you with those pitfalls. So the target audience for this webinar is actually, like Oliver said, a little higher level. So it's going to be your decision makers, people who are deciding, is Spark the right thing for me? So it's not people who are already deep into Spark or anything like that. It's going to be people who want to find out, does any part of Spark fit into what my company is looking to do? The other part would be learners, just because, again, the decision makers are going to be people potentially who are learning. So on the flip side, if you're just looking to learn more about Spark and get a very basic understanding of it, then this webinar is for you. Again, if you already are in Spark and you understand it, it's probably less so for you. So, starting with the concerns. Some of the concerns that we're going to cover today are going to be, am I too small? There's sometimes the question of, okay, I'm not Google. Do I really have to worry about data analytics? We'll be seeing how Spark can make this decision a little bit easier and not a concern. Will switching be too costly? So you already have an existing platform that you're using, whether that be Hadoop MapReduce or just anything else. Is Spark the right choice to move to? Can I utilize my current infrastructure? So you already have this big thing set up. You've got data and racks and everything already existing for your current project. Can you use what you already have? Will you be able to find developers? I mean, Spark is still relatively new. As with anything with time, it's getting better and better. And it's been out for enough time now that it seems okay, but it's still relatively new in the scheme of things. Just along the same lines, will there be enough resources available for learning, for using Spark, for just making full utilization? So, that being said, we're going to start off with the reasons why Spark has done so great. To do that, we're going to start with the basics here. So you want to run through some data. Why can't we just use grep? That's worked in the past. It runs on one machine. But once you start scaling to truly big data, that one machine is slow, and it can really cause that loading screen that we saw at the beginning. So you say, all right, well, I have Hadoop. Hadoop came along. It distributed your data. It brought the computation to the data, and it says, okay, well, I'm going to distribute my data and send all these computations and run these computations in parallel. And that definitely improved your big data processing. So your speeds and everything improved. So why do we need something better? Well, Spark came along, and it does the same thing with a fraction of the resources, while still going, it's quoted as going up to 100 times faster. There's been some improvements as of lately that could even take that number even higher, I would argue, but it hasn't been officially upped in any capacity. So 100 times improvement is still a definite big win there, plus the speed, or plus the resources that you can cut down on. So along the same lines, back in 2014, Spark broke, I don't even want to say broke, it busted the existing world record for data sorting. The existing record took 2,100 machines in 72 minutes. For the same equivalence, Spark ran in 200 machines in 23 minutes. So you can see there that it's a fraction of the time and a fraction of the resources. So just being able to cut down on your resources is definitely a big win right there. Next, we have big code. So Hadoop has had a lot of code to maintain. It's been said that you need a PhD to maintain Hadoop MapReduce. So this is a basic word count, which is kind of the hello world of big data. So it's really small, and that's kind of on purpose. It fits everything in there, but it kind of shows it takes a lot just to write a basic program. So we don't need big code anymore. Some of that's because of the power and expressiveness of Scala, but just also it's the way that Spark is written, it's just more expressive. So the same thing is much easier to read, much more maintainable, and it's also more centralized. Here's your main code. You load a text file, you split it, and you count it, and then you save it. The same thing can be done here, here, and here. So definite wins over Hadoop. Beyond the reasons that I've even said, you've got readability. We just saw that. Just by having less code, it becomes more readable and maintainable. Same thing, they go hand in hand, that it becomes more expressive in that sense. Spark runs off of a general abstraction, so you can treat your code just like collections. And we'll dig into that as we get into the basic mechanics. It's fast. I mean, we already brought that up, but it kind of made its splash in that it allows you to cache your data sets in memory. So you don't always have to hit the I/O bounds of hitting the disk. But even still, it works as a general ETL without caching. It has tons of performance gains that you can take advantage of. The other thing is testability. So people are out there and writing Hadoop MapReduce jobs and trying to test them. You have to spin up clusters. I mean, it's a horrible pain. Whereas Spark, again, it gets back to the general abstraction. It's so easily written. It's just like your regular code that you just test it like any other code. If you get into integration tests, maybe you'd have to dig into it a little bit more, but your basic modules are just any other code, so you test it just the same as everything else. It's as simple as that. Anybody who's used to Scala knows that Scala has what's called a REPL. Spark calls their version of it the Spark shell. What this gives you is the ability to be able to interact with your data and your code in real time, so you can get immediate feedback and learn a lot quicker. So you can learn about your data a lot quicker. You can learn about your bugs a lot quicker. You can test your code a lot quicker. There's so many benefits to this interactivity. It came with fault, excuse me. It came with fault tolerance built in. Whenever we discuss the mechanics, we'll dig into that a little bit more. But the gist is that if one node goes down, part of your data center goes down, then Spark is centralized enough that it will be able to be resilient, find a new node, rerun only that specific set of data, and keep going. So it doesn't have to start over again just because one node goes down. And we'll see in a little about unifying big data. To dig into that more, there's something called the Hadoop MapReduce explosion. I first heard about it at, I think, a Spark Summit. It was discussed. And the idea here is that Hadoop started as MapReduce. And MapReduce doesn't fit all types of jobs. So suppose that you want to do streaming. All right, well, now you need to pull in another project called Storm. It's built to interact with Hadoop, but it's still another library. You want a cleaner DSL, so you use Scalding. You want SQL type semantics, so you use Hive. And any number of other different use cases for big data. So this is what the Hadoop MapReduce explosion is. What it's saying is your developers don't just have to learn Hadoop. They have to learn Hadoop and Storm and Scalding and Hive. And that comes with a high cost of learning. So what Spark did is it unified together. And it's been quoted as saying, Spark will kill MapReduce, but save Hadoop. What they're kind of saying here is this unification is saying Hadoop is still a big ecosystem, and what Spark is doing is it's just trying to tackle the MapReduce complexities. So Hadoop still has validity. HDFS and other utilities within Hadoop are still very relevant. And in fact, in our Going Reactive survey that we recently put out, we see that 46% of Spark users are those that use Hadoop. And then On the flip side, 61% of Hadoop users use Spark. So there's still a large amount of people who are converting over and seeing the benefits of Spark while still using Hadoop. Now this unification that we talked about, let's dig into that further. Well, everything is built on top of what is called the Spark core. So again, as I mentioned earlier, everything is a unified abstraction. So Spark core has a common interface called an RDD, and we will see what that is shortly. But everything is kind of built on top of that one thing, so you get benefits from that. Now, whenever I say everything is built on top of that, what I'm saying is Spark core is kind of just is your expressive MapReduce. It's a way to get your ETL and run things there. But because it's so generalized, we're able to have additional extension points. Spark SQL exists for data that is structured. And because it knows that structured data, there's tons of performance gains. In fact, that's kind of where they want, where the Spark maintainers would probably want you to start with, is to use Spark SQL to start, strictly because there's built-in optimizations that you get just by working with that structured data. Just the same, we mentioned that we want fast data. So Spark streaming runs in sub-second with that fault tolerance that Spark core brings you. It gives you that same thing. So your actions are going to be, I'm sorry, I misspoke. Your transformations are going to be exactly once semantics. So you're not going to have a machine go down and then you're going to get duplicate data in your streaming. It has a ton of resiliency that you can take advantage of and still see sub-second speeds. Along the same lines, they have an MLlib, a machine learning library that brings, I kind of put it as machine learning to the masses. It's still, you still need to know the basics of machine learning, but it definitely brings machine learning a lot closer. And along the same lines, say you have a social networking graph. Well, they have GraphX to help with that. And on top of that, Spark SQL uses what's called data frames and recently data sets. And that's the kind of the RDDs on the top level. And that's just saying we have that understanding of your structured data, so we can use that across Spark Streaming or MLlib or all these other libraries and start tying even those libraries back together. There's less learning of new APIs still because you're using the same core Spark, and the only things that you need to really understand are the semantics of streaming or the semantics of machine learning, and that's just something that you're going to have to know to use those libraries anyway. Now, along the same lines, who's using Spark? There's tons of use cases that we can point out. Pandora is using it for real-time recommendation systems. Yahoo, who even was the people who started Hadoop. They have ads and other personalizations that you can take advantage of. I mean, the Internet of Things is big data at this point. Everybody is pushing data out, and trying to understand it can gain you tons in information on your customers, on ways that you can help them, on ways really they can help you. Along the same lines, we've got Netflix, who has run their Chaos Monkey against Spark Streaming. And Spark Streaming, like we said, is fault tolerant and everything. Chaos Monkey put that to the test, and it passed with pretty decent colors. Along the same lines, we want real-time fraud detection. eBay uses Spark for log aggregation, and Twitter. Twitter uses it for social networking graphs. There's tons of data in the droves that you can figure out using Spark. And one of my favorite points is actually Janelia is a science company that uses uh, Spark to stream brain information. So the impact on science and just being able to solve problems like cancer detection, things like that, it's huge with Spark. And being able to do it in a much faster timeline allows for streaming of things like brain data. Okay, with an understanding of why, how about we go ahead and get an understanding of how Spark works. So now you kind of you have a better understanding of what Spark is, why you would want to use it, some of the benefits of it. Now you want to be able to talk to your developers or talk to other people and understand some of the lingo and semantics behind it. So the first thing to understand is that Spark runs everything through a driver. Again, there are ways to make that driver highly available so that we can have a resilient reactive application. So what that does is it allows for a distribution of work to your workers. That driver is run by what's called a Spark context. And I like to think of the Spark context as the conductor of everything. So again, you saw that it's a centralized source. So what that Spark context does is it creates your tasks. It schedules your work so that everything is run appropriately. It makes sure to schedule it where the data is. So if it knows that there's existing data, it rather than sending it across the wire across your nodes, it will send the computations to your data. And along the same lines, that's how it deals with fault tolerance. This central driver knows if a node has gone down, then it will restart as best as it possibly can. It deals with caching, so it will restart and go with replication if you have that set on. So it is kind of the driving factor for things like fault tolerance and speed and taking advantage of certain performance attributes. Now, all of this goes behind the general abstraction. I already mentioned it. It's called an RDD, and what this stands for is a resilient distributed data set. So we're going to break that down. So this RDD is just a data set. Ultimately, it is an interface, but the way that it is implemented in just about every case that I've seen is that it's just a collections. You don't have to, again, it gets to that you don't have to have a PhD to learn this stuff. If you know collections, then in general, you know what an RDD is, and you know map and flat map and how to work with collections. But behind the scenes, it's still distributed. But you don't need to care. There are certain points where maybe you need to manage it a little bit more, but again, you only need to think of it as a collection. This allows you to build locally. You could build a point of or a proof of concept and deploy without any code changes. It works off of that general abstraction, and you can say, I need to run my data against an AWS cluster. I need to run it using Mesos. It doesn't care at that point. Your code doesn't care. It is the framework that will deal with the majority of that. And we already talked about resilience. It started from the first development, so it wasn't an afterthought. It was the driving factor to say, hey, we need to make sure that Spark is resilient. And we'll see how that works in a second. It's all that. And like I said, it's just a collection, so it makes it really easy. Now, some of the performance gains that Spark's able to get is because it runs most of its work off of transformations, like map, filter, and so on. these transformations are lazy. So these lazy transformations, all they're doing is building an instruction set. I've seen it equated to a recipe. So you say, I want to map my data, filter it, um, transform it in some way. All of those things don't need to be run until we get to what is called an action. When we finally work and we finally execute through collect or counting or reducing down into a final collection, once this combination of transformations and actions, it means that the driver can optimize your code. So it can use functional composition, and instead of going over your data set multiple times, it can combine your map and filter and a number of other aggregations and filters and whatever into one run. So that alone creates a lot of performance gains. So getting started is just as simple. You just go to the, I always get it backwards. I think it's org.apache.spark or it's spark.apache.org. And you just go there, you click download, you choose the version of Spark that you want. It comes as a zip file. You say there's certain ones that are built against versions of Hadoop or other packagings, and you download that zip, drop it onto your local machine, and you can just start up a Spark shell. Right here you can see all we did is run these simple lines and got back our data set right away. So that's as simple as Spark can get. You just load it, call Spark shell, Spark dash shell, and run whatever you want your code to run against. You can play with it, you can learn, and then you can build out your code and deploy it as necessary. Along the same lines, you kind of want to see where your data processing is or how it's being processed. Kind of just dig into your data. Well, Spark comes with a built-in UI. Every Spark context will spin up a Spark UI. And inside of that Spark UI, we've got things that show our completed stages, where they are, how many of them, how long. You can look at this DAG visualization so you can see how this functional composition works. So we take a text file, we run it through FlatMap, we do count by value. It's all done in the same action. It's done in the same task, and then it's output as a second stage. The next thing that we're going to take a look at is common pitfalls. We're just going to touch on this because if you'd like to dig into it more, we can in the Q&A. But just the same, you can also take a look at the recent TypeSafe AMA podcast that I did with Tom, and we discussed these common pitfalls in more detail. So some of them are that Spark is functional by nature. If you're coming in from Scala, then that's not a problem. If you're coming from Java, then you might have more of a problem with trying to think about mutating your data. Spark runs everything as immutable. Again, you have the gains of functional composition, but you have to kind of change your developer mindset. So that's something that can be difficult, but Spark tends to be able to help you with that, and you'll see it pretty readily. The infamous out of memory. Spark runs a lot of things in memory. So they've come huge leaps since their initial days where you would have out of memory all over the place. Out of memory is becoming less and less of an issue, but it still is a pitfall. Just because we're working with big data and we're trying to fit it into our data sets as best as possible. Debugging, we saw the Spark UI, that can definitely help you debug, but you still sometimes get problems with a distributed computation set. Just by the nature of distribution, that kind of makes it harder to manage and debug. But like I said, Spark UI and everything along those lines can help. There's other common pitfalls, of course, and that's kind of where we want to get to with our type-safe reactive platform. If you're looking to start with Spark, it is still fairly simple to start. It ends up with some of these common pitfalls, but there's things like Stack Overflow and other resources. If you want a more dedicated help source, then we provide support and training for Spark. Along the same lines of how we can help, we're partnered with Databricks, Databricks is pretty much considered the founders of Spark. So partnering with them has been great. Mesosphere is a big cluster manager that people use to run Spark on, and we're partnered with them, as well as Oliver pointed out, IBM is pushing out a lot of Spark improvements and a lot of areas of Spark. Along the same lines, at our core, we love open source. So we have all of these, we have support for not just Spark, but for Scala or Java or Akka or Play. Especially Spark combined with Akka can create what's called the Lambda architecture. And that Lambda architecture is very powerful in that Spark can give you your fast, resilient data, and then Akka can help keep you extremely reactive on maybe a UI side and pulling out that data, or even just making sure that Spark is running to its fullest capacity. And along those lines, we have additional utilities to help you better. Things like monitoring, availability, security. We have our expert support, certified releases, so many different things that we can help you with. If any of this is of interest to you, I highly suggest to get in contact with one of our sales representatives. Just to follow up here, we're at the end of the discussion, and so we want to make sure that we covered all of the concerns that we said we'd cover. So we said, am I too small? Well, as we saw, there's data everywhere. The Internet of Things brings data no matter what. So gleaning information about your customers, there's tons of information to be had, and Spark can help you get this data a lot easier. Is switching from MapReduce too costly? As we can see that the reduction in your resources required and having less code means less bugs. All of those things can really reduce your costs. And just the same, that something that we only gleaned over is that this general abstraction allows you to create a number of back-end sources. You may have your data sourced via Avro or sourced in Kafka or Cassandra, and HDFS, any number of sources, and it can be all pulled in and then treated as one final source. So switching just realistically can give you great gains in resources, developer productivity, a number of different areas. Can you utilize your current infrastructure? Well, as we saw, Spark just runs off of generalized abstraction in its RDD abstraction. So you just run your regular code, and then you can hook it up to any infrastructure that you already have. It doesn't. The code doesn't care about that. It's the framework that will deal with that. Will you be able to find developers? Well, I mean, Spark is a burgeoning community. Like we said, you don't need a PhD, like has been argued with Hadoop. Learning Learning Spark is, for the most part, just understanding collections. There are some of those other areas of concern that we pointed out, like moving it to a more functional mindset, but those pay off in droves as you run into less bugs with mutability, and that's especially a problem whenever you come to distributed data. So you want to make sure that your data doesn't get corrupted in some unknown way. So these developers, you just need to get somebody who understands collections, and they can spin up on Spark pretty easily. Are there enough resources available? Well, like we said, there's a ton of built-in resources. There's documentation that's provided by Spark on their website. As we just pointed out, the TypeSafe reactive platform can definitely help you there. And one other thing that I hadn't mentioned yet is something called Spark-Packages. I think it's a .org, so Spark-Packages.org. And there's a whole community that's providing other extension points for resources that can be used with Spark. So that being said, I'll open things up to Q&A, and I think Oliver was curating any possible questions.
Yes, and we do have a few. I've done my best to answer a couple of them, but for the benefit of the audience, I think one of the most broad ones is this: is Scala a prerequisite for using Spark?
So Scala is not a prerequisite. You can run Spark with just Java. So just the same as Scala is written in Java, and it just boils down to JVM bytecode. Spark has APIs in R, Python, Scala, and Java. So you can run your Java code using Spark. So I don't know if I would necessarily say it's a prerequisite. It's kind of built in.
Alrighty. At the same time, Spark is written in Scala, and I think that both our recent report and the report from Databricks shows that Scala is, although not a prerequisite, it's certainly the most popular programming language, and a couple others are Python and R, correct?
Correct. And I will agree with that. So Scala, Spark was written in Scala for a reason. The expressiveness that you gain, some of the expressiveness that you gain that I mentioned is just in due part due to the Scala nature. So some of the speeds and developer productivity and a number of other resources, I think Scala is probably the best. If you're looking to start out with, Scala is probably the best way to start.
Alrighty. Um, let's see. One of them is about, since you mentioned Apache Storm on one of your slides, and I'm not sure if you're able to give too much detail on Storm, but the question is, do the features of Storm overlap with Spark, or are they rather, where does the overlap, if any, occur between Storm and Spark?
So Storm and Spark streaming in that case are actually pretty similar. I'm not too much of an expert on Storm, so I can't give a perfect answer here, but what I can tell you is that the biggest difference is that Spark streaming is considered micro batching, and that gets to its nature of RDDs. Everything is just a bunch of little RDDs, whereas Storm is true streaming. The biggest thing there to take away from there is that because Spark streaming is built on these mini batches of RDDs, it gains that exactly once semantics and still has very, very fast speeds. Whereas Storm, you have to throw in something like Trident to get those exactly once semantics, and once you throw in Trident, your speeds start to slow down. So their API sets are probably pretty similar. their performance, I would probably, if I were choosing to start with something, I would probably start with Spark streaming. I think even Storm is not being maintained as well by Twitter. That's an unqualified response there, but by what I've heard, uh, the Storm is kind of falling to the wayside, especially whenever it comes to competition like Spark streaming.
Alrighty. A couple questions have asked the same thing regarding Yarn and Mesos. Justin, do you have any personal experience with, or do you have any recommendations for running Spark on Mesos versus Yarn, or rather, yeah, exactly. So, what are the benefits of running Spark on Mesos over Yarn, and do you have any experience to share with that?
So if you're already running HDFS and Hadoop and you already have Hadoop set up, Yarn is probably the way to go there. But even still, Mesos gives you a lot more of a generalization. Yarn is very Hadoop centric. So if you're in the Hadoop stack, Yarn is probably a decent choice to choose because you've already got things built in. Whereas if if not, or even still, looking at Mesos, Mesos allows you to throw in things like Akka and Cassandra and just a bunch of other different uh, uh, distributions at a more general scale, as well as Mesos comes with a coarse and fine-grained mode, so it gives you a little bit more control over your resources, and they're how dynamically they're created. There has been work on dynamic allocation and Yarn and other things, but it comes built in with Spark or with Mesos. So overall, I would I would suggest Mesos just because it's a more generalized cluster manager.
Alrighty. Um, along that same line, one question is Spark uses in memory models, but can also be used with Hadoop's HDFS. How does that work exactly? Does Spark load HDFS data into memory?
Yes. So basically, again, it gets back to that the RDD is a generalized abstraction. So anytime that you are loading your data, it's going to load it from its initial source. So it will load the data initially from something like HDFS or Cassandra or wherever you're storing it. But after that, you can call on the RDD, you can call cache or persist, which give you different varying levels of maybe cached replication of if you want it to be in memory or if you want to cache to disk and memory or just disk, different levels of caching. But the key point there is that once you've loaded the data and you've instructed it to cache your data, it's going to cache your data however you've instructed it to. By default, that's going to be in memory. So what that is it's going to say load from HDFS. Once you've loaded it, cache it as long as you've told the RDD to cache it. And then any further executions that you run against it will be run against that memory, whatever data is in memory. And again, that gets to the Spark context and knowing where it's stored in memory, on what node it's stored on, so that it can still be quick. I've personally found some definite benefits in using caching inside of the Spark shell, because at that point you can load a very large file as long as you have the memory to handle it. You cache that, and then you can that initial load. I've had things that take in my local testing, so it's not necessarily distributed at that point. I've had things that take maybe 5 to 10 minutes to load just because it's that large of a data set, and then I cache it, and then things run in seconds. So interacting with your data is a lot better whenever it comes to that cached data. So just to kind of wrap that up, basically, it still reads the data from HDFS or whatever your data source is, but once it's cached it, it will read it from memory, but it still has that underlying execution graph so that if something fails over and that's no longer in memory, it'll go back to the disk. So everything still is underlying the disk. It's more about putting kind of a proxy in the middle.
All right, great answer. We've got time for a few more questions, I think. One of them goes back to the programming language choice, and verbatim, the question is, when it comes to performance between Scala and Java, which one is preferred? Are there any specific metrics available?
Um, I will, as far as metrics, I will have to get back to you on that. I don't know off the top of my head about metrics. I do believe that there are some performance gains that you get from writing things in Scala. Um, but that being said, if you start off with something like Spark SQL's data frames and say your data is structured or you're able to put it into a structured data, um, then because Spark has that structure, you can write your Java code, your Python code, your R code, your Scala code, and it will all boil down to the same JVM code. So the performance, any performance gains that Scala does have, if you're using something like data frames, a lot of those performance gains drop down to the same thing. So especially if you're using something like Python, Python especially has a hit whenever it comes to its performance. And using data frames, that abstraction generates a lot of the JVM code for you, and it ends up having the same performance no matter the API. Now, if you're going off of the core API, I think the best performance you're going to get from it is Scala, but I will have to double back on any true metrics.
Alrighty.
Probably pretty similar.
Yeah, yeah. I suppose the fact that generally Scala requires less lines of code overall than Java might be a consideration, but I'm not sure about how performance is affected as you just explained. So the last question is going back to one of your concerns: is my data too small? What's the smallest scale data set where Spark makes sense? The questioner said that they've had to put off using Spark because they can only do so much in memory on a single machine.
So that's actually kind of a hard question to answer. Um, I assume that there will be a resources, Oliver.
Sorry?
Will I will I be able to provide resources after like a link or something on the
Yeah,
blog?
absolutely. We can definitely include that in the follow-up email that we send to everybody, including the slides and recording of this webinar.
Okay, so what I will do is I will point out, I forget their exact links, but there are two blog posts that people have made about kind of gauging your data set size in general against big data, whether it's Spark or MapReduce or anything. And basically what they say is, one is called like Hadoop hatred. It's a bit of an inflammatory article name, but it's actually a pretty well-written article saying that you should maybe look at using something more like a grep if your data is only in a few megabytes or gigabytes or something like that, and it kind of scales up with that. The other one is actually pointing that they had huge performance gains using something like grep instead of a distributed framework. And again, it all gets to probably what you're doing with your data, maybe how dense your data is, So if you're doing something like machine learning, um, the machine learning against a smaller data set is going to be performance intensive anyway. If you're just talking about ETL, you're probably going to want to be in the at least hundreds of gigabytes into the terabytes, but that's an unqualified answer in that each person's data is different. So that's why I think those resources to those blogs covers that topic a little bit better than I can in a short blurb. Um, if
Yeah.
you're if you're able to run on one machine, then go ahead and run on one machine. But the way that data is ramping up, it seems like we're getting more data than we can handle nowadays, and that's only going to increase.
Oh yes, that's one undeniable fact there. Well, Justin, thank you very much for your time today. Everybody who joined us, thank you for joining. One final note, there's quite a few very interesting questions in here that are a bit too complicated to go into on this live recording. Uh, for those of you that are TypeSafe subscribers, you can log into your account and ask your technical questions directly to our support engineers who will respond with detailed information. And this is one of the great things that comes with a TypeSafe subscription for your team. Otherwise, you can probably catch up with Justin at some point on Stack Overflow, where we did mention he is a very active committer, and there's always some good resources to be found on the internets. Uh, However, but like I said, if you are an existing subscriber with TypeSafe, you can log in and answer or ask all of your technical questions directly to a Spark engineer on our team. So again, thank you very much for joining us today, and you'll receive an email with a couple links as well as the webinar recording and slides in the next few days, probably by Monday of next week. So Justin, again, thanks very much for joining us, and I hope everyone has a wonderful day and weekend.
Thank you.
All right, bye-bye.